Hello, this is Kim. Today we'll cover about the VCO, voltage control oscillator. Okay, let's see. On the oscillator, you basically have a four waveform: sine wave, triangle, sawtooth, and square. Okay. Today we are just reviewing square because we want to see what's the definition of the pulse width. Okay, but I'm going to cover about the sawtooth as well. Okay, let's see. Yes, this is a sine wave. Okay, this is called frequency. So what frequency means? How many cycles does it happen within 1 second? If this happens in 1 second, this is 1 hertz. But if this is 1 second, then it'll be 2 hertz. Okay, 2 Hz, right? So what we need to understand, each of this frequency component, which I call harmonics, is a single sine wave. You can represent this with a single sine wave. Okay, this is a single sine wave. Each of these are single sine wave. Okay, so that means if we use the sine wave as a sound, right? We can bend the pitch, right? This is a sine wave. So what it means is a sine wave doesn't have any frequency component. It's only one pitch information. That means the sine wave doesn't have all this information. Just this one. Or just this one. Without all this information. Okay? So it's a single frequency information. That's why it sounds so smooth. On the other hand, triangle has some more frequency. We'll cover about this later on, about frequency component and its rule. But you can consider from sine wave to triangle and to sawtooth and square, it's getting more sharp sound. It's getting more sharp sound. You see, this is more smooth, right? And this is more sharp, right? And this is more sharp, and this is more sharp. But the difference between square and sawtooth has more like it's really fast sound. Okay, it's a really fast sound, and it's more like a mid-range sound. This is more like a high-range sound, right? But the interesting thing is when you hear the sawtooth and square, and if you increase the pulse width, it's similar, right? So what I'm trying to tell you right now, the frequency harmonics, the harmonics amount is increasing from sine wave, triangle, square, sawtooth. Okay, sawtooth has a lot of frequency harmonics, which means it has a lot of this one. That's why it sounds so rich and full. On the other hand, the sine wave is so smooth, and triangle is a little bit more, right? You heard the difference? Right? Okay, we covered this one. Now, if you want to modulate, if you want to control the pitch of the VCO, you just need to connect the 1 volt per octave, which is the pitch information, the input, right? That'll control the pitch. We covered this, right? Now, what I want to cover about is okay. I think we have to cover this later on the FM. Okay, we are not able to cover this dip right now. But what I'm trying to explain is the FM means a frequency modulation. Okay, frequency modulation. It means it's modulating frequency with this input. Okay, let's see. Okay, let's see. LFO, which means low frequency oscillator. Okay. Now, what I'm trying to do is I'm going to modulate this oscillator with the LFO. It's same as a oscillator, but it's on low frequency. Okay, we'll cover this later on, but you don't need to worry about it. But what it means is, as you can see, it's going up and down. It's going up and down, right? It's going up and down. Now, what I'm trying to do is I'm going to increase the frequency modulation index, which means how far I want to modulate this VCO. Okay? Right? Right? It's interesting sound. As you can see. Let's see. Now, you can see the frequency, the times, the waveform is getting bigger and smaller, right? The red wave, right? That's because we are modulating. Modulating means changing, okay? Giving a variation to frequency with this blue line, okay? If the blue lines goes up, it gets more it's getting more change. So the wave will be happen more frequently. Let's see. You see? Then we need to understand what it means. If this frequency is high, okay? If this is high, the blue, right? It's getting high. The red waveform will squeeze in the same period, which means it'll have a more frequently happening in the 1 second, right? That means it'll have a high frequency. High frequency means you'll have a high pitch. That's why it's going up and down, right? Does it make sense? Right? Now, we have another thing with the pulse width modulation. Let's see, with the square wave. If I increase the pulse width modulation, you hear the richness of the sound is changing. Right? It's changing the pulse width of the square wave. It's changing the pulse width of the square wave. Let's see. It's changing this one with this one. right? Makes sense, right? Okay, this is it for today. So we cover the basics of the oscillator. Thank you.